Hello viewers, in today's class we are going to solve one important definite integral involving greatest integer function, right? So here we have to integrate this function from 0 to infinity, and the function is greatest integer x multiplied with e raised to minus x, right? So let us call this integral as I, right? So now here we see that the limits are from x equal to 0 to x equal to infinity, right? So if we have the number line here, and here we have 0 and here we have infinity, then we see that there are integers 1, 2, 3, 4, 5 and so on, right, up to infinity, right? So what we will do, will break this integral into uh, several integrals. That is, the first integral is from 0 to 1, right? From 0 to 1, then from 1 to 2, right? From 1 to 2, then from 2 to 3, right? 2 to 3, then from 3 to 4, then from 3 to 4, and similarly from 4 to 5, right, and so on. So here we have written this integral as a sum of these infinite number of integrals, right? That is, will evaluate this function at the integral points, right? Okay, so from 0 to 1, 1 to 2, 2 to 3, 3 to 4 and so on, right? So here we have the function greatest integer x e raised to minus x dx. Similarly here also we have greatest integer x e raised to minus x dx. Here also we have greatest integer x e raised to minus x dx. Similarly here also greatest integer x e raised to minus x dx, and here also greatest integer x e raised to minus x dx and so on, right? Now to proceed further, let us make use of the property or the definition of greatest integer x, right? So we know that whenever x lies between 0 and 1, then the value of greatest integer x is equal to 0. Similarly, when x lies between 1 and 2, then the value of greatest integer x is 1, right? Similarly, we can write 2 here, and here we'll have 3, then the value of greatest integer x is 2. And similarly, when x lies between 3 and 4, we have the value of greatest integer x as 3, right? Similarly, we can write here we have 4, here we have 5, and the value of greatest integer x is equal to 4 and so on, right? Okay, so now this property will be utilized in order to evaluate these integrals, right? So now we can write I is equal to, see here we have 0 to 1, and when x lies between 0 and 1, then the value of greatest integer x is equal to 0. So here we'll write 0 times e raised to minus x dx, right? Similarly, when x lies between 1 and 2, then the value of greatest integer x is equal to 1. So here we'll have 1 times e raised to minus x dx. And similarly, when we have the integral from 2 to 3, the value of greatest integer x is equal to 2, and here we have e raised to minus x dx, and similarly from 3 to 4 the value of greatest integer x is 3, so here we have 3 times e raised to minus x dx, and when we have the value of x from 4 to 5, then the value of greatest integer x is 4, and so on, right? So we'll have this expression, right? So using the definition of greatest integer x, we have simplified this expression to this one, right? Okay, so now the value of I is this integral is 0, and then we have here we have minus e raised to minus x, and the limits are from 1 to 2, right? Because the integral of e raised to minus x dx is equal to minus e raised to minus x, right? Okay, so now let us write the value of this integral. So here we have 2 outside this integral sign, and we have minus e raised to minus x, limits are from 2 to 3. Then we have here we have 3, taking 3 outside the integral, we have minus e raised to minus x, limits are from 3 to 4, and then we have 4 times minus e raised to minus x, and the limits are from 4 to 5, and so on, right? Okay, so now we can easily simplify this expression by writing I is equal to, so here we can take minus sign outside and substituting the limits, so we have e raised to minus 2 minus e raised to minus 1, right? And here again we'll take minus sign outside, so we have minus 2 e raised to minus 3 minus e raised to minus 2, right? Substituting the limits and taking the difference, right? Similarly here we have we can take minus 3 and e raised to minus 4 minus e raised to minus 3, right? And here we have minus 4 and e raised to minus 5 and minus e raised to minus 4, and so on, right? Okay, so now we can further simplify this expression by writing I is equal to, taking this negative sign, multiplying these two terms by this negative sign, we have minus e raised to minus 2 plus e raised to minus 1. Here we have minus 2 times e raised to minus 3, then we have plus 2 times e raised to minus 2, and here we have minus 3 e raised to minus 4 plus 3 times e raised to minus 3, and then we have minus 4 times e raised to minus 5 plus 4 times e raised to minus 4, and so on, right? Okay, so now let us simplify it further by simplifying the like terms. So here we have this term is e raised to minus 1 and minus e raised to minus 2, and plus 2 times e raised to minus 2 is plus e raised to minus 2, and then we have minus 2 times e raised to minus 3, and 3 times e raised to minus 3 is plus e raised to minus 3, and then minus 3 times e raised to minus 4, and 4 times e raised to minus 4 is plus e raised to minus 4, and similarly we'll have e raised to minus 5 plus e raised to minus 6 and so on, right? Okay, so now we have this infinite series, and now if we see this series, then this infinite series is an infinite geometric progression, right? So this series is an infinite geometric progression whose first term is e raised to minus 1, right? So a is e raised to minus 1, and the common ratio of this infinite geometric progression is given by r is equal to second term divided by the first term, right? So e raised to minus 2 divided by e raised to minus 1, which is e raised to minus 1, right? Okay, so now we have to find the sum of this infinite GP. Now if we have an infinite GP as a plus ar plus ar square and so on, then the sum of this geometric progression is given by a divided by 1 minus r, right? So the sum of an infinite GP geometric progression whose first term is a and the common ratio is r is given by a divided by 1 minus r, right? So this infinite series is an infinite geometric progression whose first term is e raised to minus 1 and the common ratio is e raised to minus 2 divided by e raised to minus 1, that is e raised to minus 1, right? So this integral is now equal to, for a we have e raised to minus 1 and for r we have e raised to minus 1, right? Okay, now we have to simplify this expression. E raised to minus 1 is 1 over e and this is 1 minus 1 over e, right? So this is 1 over e and this is e minus 1 over e, right? So here e is the exponential number, so now we can write 1 over e times e over e minus 1 and see this e and this e get cancelled, so we are left with 1 over e minus 1, right? So the sum of this infinite geometric progression is 1 over e minus 1, which is nothing but the value of this integral, right? So the value of this integral is 1 over e minus 1.